Hello guys, welcome to my tutorial on how to use 2D sprites with the IE system for Mecanim. First of all, you should install the 2D support package and attach the script sprite again. Just drag and drop it onto your sprite, and then we need to set up it a little bit. So the radius and the height. So it fits your sprite. Two. Okay, I think it's fits now. Well, then you can attach a physics material. This is the material on the head of your sprite. So if a player jumps on it, maybe he jumps up. So choose simply bouncy. Uh, well, I'm using the animator controller that comes with the 2D sample assets. I have just configured it a little bit, so I have a full jump as an animation. Yeah, and everything else is equal. Okay, then we have to do the same as for the 3D system. So we need to drag and drop the IE runtime controller and well create an IE controller. I've created one already. It looks like this. So we have idle state, follow state, and traverse link. In the idle state, I'm setting the speed to 0. Then I'm finding the closest target that is tagged as player and flip towards. Our owner sprite flips or basically looks towards the target. And here I'm checking if the target is not null and if the distance to the player is greater than 2. Here I'm ignoring the epsilon axis, so the vertical distance is ignored. So if the player is above the agent, he does not follow him if there is no jump link or yeah. In the follow state we have to define our target, speed, threshold, just the same as in the other states and the jump state. So if we hit a jump link, basically this one is a jump link, um, it should well execute or play the jump animation state. Then we set the speed to 1 and here the condition back to idle if the distance is less than 2, the horizontal distance, and if we are not on the jump link, we can switch back to idle. Then I have another state. This is a simple state where I'm just saying if we are on a jump link, if this is true, and if we are not grounded. So you have to define the ground by a mask. I have set this one as floor, and also a cube here. Uh, Set the layer as floor, and here I am simply saying, oops, sorry, if we are not grounded, we will transition into this state, traversing, and we transition back to follow if we are grounded again. Yeah. Then we have to add a rigid body to our agent. So let's add a physics 2D, rigid body 2D. Well, you have to play with the values here, and I'm using the default rigid body values that comes um, with the sample assets. It's set up pretty good, so I will just copy this component, copy component from a ready-to-go sprite agent, or this my player has the same rigid body values. I just copied them from the player that comes with the sample assets and pasted it on my agent. So I will just paste them here, paste component values. I only changed the mask so the player can't push our enemy. If you want the player to push the enemy, you can lower the mask. Yeah, let's disable our others other enemy, and yeah, that should be it. So we can try this out. Well, now he follows us. Oops, we're here, and as you see, if we jump on the head, our player jumps up because of the physics material here. What the system does, what the sprite again does, is just adding the colliders to our agent. So let's see. Okay, I think you can't see this. So let's disable the background so you can better see the colliders. It's a simple box collider here and two circle colliders. Yeah, that's it. Well, and let's see how we can use the jump links. Basically, you can create a new game object, create empty, and then you can add the jump link script on it by dragging and dropping it here. Then you have to set the agent radius. It does not need to be the same, it's just a scale value for the colliders that are created when the agent is here. So it can be it can have a difference between the agent radius and the value here. It's just a scale value, so we don't need to create such big colliders here. Yeah. Then we have the traverse time, how long it should take to traverse from uh, the jump link here to the end of the jump link. And we have the start of the jump link. I am always dragging and dropping simply the jump link itself to this transform, and then I create a new game object and drag the new game object here to the end field, and then we can set if the agent can jump from the end to start. Well, that's basically it. So this looks like this. Um, I have the jumpling itself, it's the transform itself, then the end jumpling, or simple end transform that you can position. Um, yeah, and a traverse time of 0.8, and then it looks like this. Let's see where, I think it was here, 0.8. So it takes 0.8 traverse time, and if you rise it, let's do it. So let's maybe say 1.5 seconds to traverse from this to the end, then it will look differently. He will jump higher, okay, as you see, and yeah, need to play around with the values. If you have here colliders, then yeah, just play around with the traverse time. You can't change it at runtime. You can, but you need to change it then on the jumping end also. So let's do this. Maybe let's set this to 1. Then we need to select this jumping again. So the end of the jumping, and then set here the value also to 1 if you have a bidirectional value. Yeah, if you wanted, of course, to change at runtime, and if you change it at edit mode, then you have to set this traverse time once. Yeah, and then let's see. So now he traverses, and 1 second. Yeah, if you change it, for example, maybe let's say here a little bit lower to 0.6. Well, maybe you don't see this. Yeah, let's change it to 4. As you see, he jumps not that high, and here again at a normal speed. Okay, that should be it. Thank you.